Hello, welcome to MENM Academy, that means Moksha Nagasi Maths Academy. Today I am going to explaining standard 10th mathematics. Okay, that topic is introduction to trigonometry. Okay, so most of the people, most of the children, we are getting the trouble regarding this topic. Okay, first I will explain that what are the general topics. That means what are the general principles in this trigonometry. Okay, that means according to trigonometry, the whole trigonometry is totally based on the right angle triangle. Okay, first you can draw the right angle triangle in any manner. See children, A, B, C, right angle at B. So ABC is a right angled triangle. So before going to the ratios of the trigonometry, okay, first we have to identify that from this trigonometry, what is opposite side, what is adjacent side, and what is hypotenuse. Okay, that means you have to identify whenever you know that this is the right angle triangle, the other two angles are acute angles. That means angle A and angle C are the acute angles. So to identification of the angle, just you have to think that suppose theta is the one of the angle at the point A. That means theta opposite side what is there? BC. That means the side which is opposite to theta, it is called as the opposite sides. That means BC is the opposite side. Right angle opposite means hypotenuse. That one you know that you learn already in the 8th standard only. So right angle opposite side is hypotenuse. That means AC. Okay, the side which is opposite to right angle, it is called as a hypotenuse. This is the hypotenuse. Okay, children. Then what is the remaining side? AB. That means the side which is adjacent to theta, it is called as adjacent side. Okay, that is the adjacent side. If you want to write, you can write fully adjacent side. Okay. Generally, we can identify these the sides. The side which is opposite theta is opposite side. The side which is opposite to right angle is hypotenuse. The side which is adjacent to theta is adjacent side. See, by using these all the three sides, so you can identify the trigonometrical ratios. The mainly they are the three trigonometrical ratios. Okay, children. How many? Three trigonometrical ratios. They are the first one sin theta. SINE, actually the shortcut is sin. So sin theta is equal to, the rule is belongs to the ratio of opposite side and hypotenuse. Simply you can say that, you can write simply opposite side by hypotenuse. Shortcut you can write HYP. Opposite side by hypotenuse. And second one is cos theta. Actually question, children, the short form is cos theta. Cos theta is adjacent by hypotenuse. That means adjacent side by hypotenuse. Adjacent side by hypotenuse. That is cos theta. And the third one is tan theta. Actually tangent, children, you know that. Okay, the short form is tan theta. Tan theta is the ratio of opposite and adjacent. That means opposite side by adjacent side. Opposite side by adjacent side. The mainly these are the three trigonometrical ratios. So for these reciprocals will be there, still more three ratios. Sin reciprocal is cosecant, cos reciprocal is secant, and tan reciprocal is cot. So that means reciprocal means you know that numerator becomes denominator, denominator becomes numerator. So with respect to sin, cos, and tan, we can write that fourth one is cosec theta. Cosec theta, COSEC, otherwise CSC also we can write. Actual cosecant short form is cosec theta. Cosec theta is what I told you, reciprocal of sin theta I told you. Sin is opposite by hypotenuse. So that cosec means hypotenuse by opposite side. Simply shortcut you can write hypotenuse by opposite. And next one, fifth one, cos theta. Cos theta reciprocal is sec theta, right? Sec theta equal to this reciprocal, children. Okay, that means hypotenuse by adjacent side. And tan reciprocal is cot. That means cotangent, children. Actually, the short form is cot. That means cot theta. Okay, cot theta is equal to, what is that, this reciprocal, I told you. That means adjacent side by opposite side. Adjacent side by opposite side. Actually, these are the totally six trigonometrical ratios. Okay, the main three ratios are sine, cos, and tan, and their reciprocals cosec, sec, and cot. See, now using this sine, cos, tan, cosec, sec, cot, then you can write now reciprocal properties in a trigonometry. Okay, children. Just now I told you what are the reciprocals. So by using that, we can implement trigonometrical reciprocals. They are called as the reciprocal properties. Okay, reciprocal properties. Trigonometry, in this trigonometry. Reciprocal properties. So what are they? See, children. What are the reciprocals I told you before? Sin theta. Sin theta is the reciprocal of cosec I told you. That means sin theta is equal to 1 by cosec theta. That means whenever sine is the reciprocal of cosec means cosec is the reciprocal of sine. You know that. So that we can do by using this rule, by doing the cross multiplication. Sin theta into cosec theta. Sin theta into cosec theta. Sin theta into cosec theta. What is the answer? 1. Okay, children, this is the one. Okay, next one, second one, cos theta. Cos theta is the reciprocal of sec theta. That means 1 by sec theta. 1 by sec theta. Then cos is the reciprocal of sec means sec is the reciprocal of cos. See, by using this cross multiplication, we can say that cos theta into sec theta equal to how much, children? 1. Okay, and the third rule. Third one, what I told you, tan is the reciprocal of cot. That means tan theta is equal to 1 by cot theta. Tan theta equal to 1 by cot theta. Tan is the reciprocal of cot, then cot is the reciprocal of tan. So that by using this cross multiplication, children, what you will get? Tan theta into cot theta. Tan theta into cot theta equal to what? 1. Okay, these are the reciprocal properties. Next, I gave you before that sine is the ratio of what is that? Opposite side by hypotenuse. Opposite and hypotenuse. Like that I gave no. Cos is adjacent by hypotenuse. Tan is opposite by adjacent. See, now according to that, see, still more you can implement the some of the rules. So what are the rules? Whenever you are taking that, see what some of the rules here. Simply tan theta also we can write the ratio of sine and cos. tan theta equal to sin theta by cos theta. Why? Because actually tan tan rule is what? Opposite by adjacent now. So whenever you're taking that sine and cos, sine by cos, no. Sin theta means opposite by hypotenuse. Cos theta means adjacent by hypotenuse. Hypotenuse will be cancelled. No? What will get? Opposite by adjacent, which is equal to tan theta. No? So that we can say that tan theta is the ratio of sine and cos. That means tan theta equal to sin theta by cos theta. From this we can get it sin theta value and cos theta value from this relation according to the general rule of that means algebra. Sin theta is equal to what? Tan theta into cos theta. Then cos theta is equal to sin theta by tan theta. That means if you know from main rule this, from that you can derive sin theta and cos theta. And the second one, tan is the reciprocal of cot, I told you. That means cot theta. Whenever it is tan theta equal sin by cos means cot theta equal to cos theta by sin theta. Cos theta by sin theta. Okay, children. So these are the general rule. Actually, next when you are going to the last exercise in this chapter, that is one of the highlights, main most probably, because of in that exercise all the trigonometrical identities are applicable and all the most probably algebraic identities also it will be useful. So that exercise they taken as a very important concept, very important. Okay, so that before going to that exercise, still more algebraic, that means trigonometric identities, you should know that. So what are the trigonometric identities? Just I will explain. See, children. Trigonometrical identities. Trigonometrical identities. See, children. Okay, the mainly trigonometrical equations. Okay, they are the three equations, children. Okay, so that what is the first one? With respect to theta, if you take that sine square theta plus cos square theta equal to 1. Okay, this is one of the identity. And second one, sec square theta minus tan square theta equal to 1. Third one, cosec square theta minus cot square theta equal to 1. Cosec square theta minus cot square theta equal to 1. See, children, if you know very well these three three formulas, from this you can derive from the first equation we can derive sine value and cos value. Sine and cos we can derive. You know that according to algebra. Plus becomes to minus, minus becomes plus. According to that we can say that sine square theta equal to 1 minus cos square theta. Otherwise cos square theta equal to 1 minus sine square theta. From that sine theta and cos theta easily you can get it. You know that. So in the same way, sec square theta minus tan square theta equal to 1. That means sec square theta equal to 1 plus tan square theta. Okay. Next one, cosec square theta minus cot square theta equal to 1. Then cosec square theta equal to 1 plus cot square theta. We can say that whenever you are taking that sec square theta equal to 1 plus tan square theta, then what will become sec square theta minus 1 is equal to tan square theta. That also you can identify, no? Same thing, cosec square theta equal to 1 plus cot square theta. That means cosec square theta minus 1 is equal to cot square theta. Okay, so you know that these are the mainly trigonometrical identities. Okay, from these three identities also we can prove that by using this right angle triangle or by using the two-dimensional geometry. That means by using x-axis and y-axis also, by using the unit circle. So other than that, directly by using this triangle, easily we can prove these all the three identities. See children, how to prove these three identities. Whenever taking these are three identities, there is no particular order. Actually, generally we can say that sin square theta plus cos square theta equal to 1, first one. Second one is sec square theta minus tan square theta equal to 1, other cos square theta minus cos square theta equal to 1. There is no rule. See now what we will get. Before going to that, before proving this all, we must know that Pythagoras theorem, children. That means whenever you know this right angle triangle, immediately you have to remember the Pythagoras theorem. So Pythagoras theorem is saying that, what is that? The square of the hypotenuse. The square of the hypotenuse is equal to sum of the squares of the adjacent side and opposite side. And also you know that in a right angle triangle, which is the largest side? Hypotenuse. So that according in that, easily you can say that the square of the largest side, that should be equal to the sum of the squares of the other two sides. Okay. So you can say in any manner that definition. So now according to this triangle, by using the Pythagoras theorem, according to Pythagoras theorem, according to Pythagoras theorem, according to Pythagoras theorem, what will become? You will see that. According to Pythagoras theorem, we get what you are getting. AC square is equal to AB square plus BC square. AC square equal to AB square plus BC square. This is main equation, children, to get the trigonometrical identities. All those three equations. Okay. Think that this is equation number 1. Okay. So you know that in this equation there are the three sides, no? Okay. Each side you can divide on both the sides, then we'll get one equation. There are three sides mean three equations, right? First you can see that dividing this equation by AC square on both the sides. Simply you can write divided by AC square or dividing by AC square on both the sides. On both sides. You can write like this also, know that. How to write now? With AC square you can divide. AC square by AC square equal to, this is AB square by AC square plus BC square by AC square. Now just you can simplify. A square in AC square how many times? One time cancel. So that the remaining equation, the given this equation can be written as 1 equal to AB square by AC square. AB square by AC square, you know that you can write like AB by AC whole square. AB by AC whole square we can write. Plus BC square by AC square, how to write? BC by AC whole square. Okay. Now AB by AC and BC by AC belongs to what? From this triangle. That we have to mention, since AB by AC. AB by AC. What is AB? What is AC? In this diagram you can see. AB is what? AB is adjacent side. AC is what? Hypotenuse. Adjacent by hypotenuse. What you call? Cos theta. Right? Next, BC by AC. BC by AC. What is BC? What is AC? You can see. BC is opposite side. AC is hypotenuse. Opposite by hypotenuse, what you call? Sin theta. It is belongs to sin theta. So that this reason we have to use by elimination of this. So that this equation can be written as 1 equal to, see children, be carefully, 1 is equal to AB by AC. AB by AC means what? Cos theta. Whole square means what you will say? Cos square theta plus BC by AC. BC by AC means sin theta. BC by AC whole square means what? Sin square theta. Don't write that sin theta square because theta is the angle. Okay. 1 is equal to cos square theta plus sin square theta. This is also can be written as okay sin square theta plus cos square theta equal to 1. This is the first proof, no? Okay, one of the trigonometrical equation, right? Now, we are divided with AC square now. Next, it goes to this order, AB. Means, particular order is not there. You can take up with BC also, okay? So, if it goes like this line, you don't need to be confused this. So, take the, again, the first equation divided by AB square on both the sides. Okay, children, that also we'll see that. Divided by AB square. Same equation divided by AB square on both the sides. Then what we are going to getting? We get. If you won't write also no problem, children. No need to confuse. See now. Check second proof I am going to prove in. We get means what you are dividing with AB square. Of which equation? First equation. The main thing is the first equation, no? Dividing by AB square on both the sides. That means how to write now? AC square by AB square equal to AB square by AB square plus BC square by AB square. So where is the cancellation? Here. One time. So AC square by AB square, what is left now? AC square by AB square, that can be written as AC by AB. AC by AB whole square equal to, here 1 is left now children, 1 plus BC square by AB square. This can be written as, you know that, BC by AB whole square. Now what we have to eliminate? AC by AB and BC by AB. Okay, what ratios will become? We'll see that. See children, AC by AB. AC by AB. What is AC? Hypotenuse. What is AB? Adjacent. Hypotenuse by adjacent. Hypotenuse by adjacent means what you call? Sec theta. Okay. Next one, BC by AB children. BC by AB. BC is what? Opposite side. AB is what? Adjacent side. That means opposite by adjacent. Opposite by adjacent is tan theta. Okay children. See now. Now we can eliminate. This can be written as now AC by AB. AC by AB means sec theta. So that AC by AB whole square means sec square theta equal to 1 plus BC by AB. What is BC by AB? Tan theta. That means whole square means tan square theta. Sec square theta equal to 1 plus tan square theta. Actually it is proved. If you want that tan square theta, you can take this side. Plus becomes minus. You know that this can be written as sec square theta minus tan square theta equal to 1. This is the second equation children. Okay, na? Sec square theta minus tan square theta equal to 1. So the remaining equation is there. Here also remaining side is there. Already these two sides are completed. What is the remaining side? BC square. So that take this same equation divided by BC square on both the sides. Dividing with BC square on both the sides. So what will become, you can see. So that the given equation can be written as, when it is dividing with BC square, so that how to write children? BC square by BC square equal to AB square by BC square, AB square by BC square plus BC square by BC square. Right? Now, BC square in BC square, how many times? One time will be cancelled. Now, AC square by BC square can be written as AC by BC whole square equal to AB square by BC square can be written as, how to write? AB by BC whole square plus 1. Okay, now AC by BC and AB by BC have to get it now. What ratios will become from this triangle? You'll see that now. See children, AC by BC, AC by BC. That means what? AC means hypotenuse, BC means what? Opposite side. So that hypotenuse by opposite, what will come? Cosec theta. Next one, AB by BC, AB by BC. What is AB children? Adjacent. By BC. What is BC? Opposite. Adjacent by opposite. Adjacent by opposite means what? Cot theta. Now you can utilize these two ratios. So then we can eliminate from this and this. Now in the place of AC by BC is cosec theta. Whole square means cosec square theta. Right? Equal to AB by BC. AB by BC means cot theta. AB by BC whole square means cot square theta. Plus how much? 1. Until here over actually. Otherwise what I told you, plus cot square theta if you take here, minus cot square theta. So that this can be written as cosec square theta minus cot square theta. Cosec square theta minus cot square theta equal to 1. So these are the mainly trigonometrical equations. Okay children. So these are the applications you are using at the last exercise. Okay. Still more exercises are there between that. Okay, now that means by using the general properties and by using some specific angles 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. I will explain, I means mainly I will complete that last exercise, then I will go to that. After that complementary angles will be there, 90 minus theta and 90 plus theta. Actually it is not there in the syllabus, but I will explain. See children, now we will go to directly the last exercise. In that last exercise also, children, the last Roman it is there. In that last Roman, they have the 10 questions are there. They are the 10 bits. Simply don't think that they are the bits, 10 questions. Each question is very, very important. So, every question is very important because of concepts are applicable. These are all the trigonometrical ratios and identities. That's why they take in the important topic that is. Okay, from that exercise, definitely we will get 1 or 2 sums. Okay, in board examination and other exams also. Okay, we can see, be carefully, be concentrate and perfectly we can see that. In the previous videos, I gave you some algebraic identities. Okay, children. So those identities also must be keep in your mind. Okay, then only it is possible to get it completely in that exercise, that last Roman. Okay, see, be carefully.